All right. In this problem, 8.18, they give you a reaction and they want you to calculate the change in enthalpy from it using the bond dissociation energies. Remember your formula for using the bond dissociation energies is the change in enthalpy of the reactants, of the change in enthalpy of the reaction is the sum of the bond dissociation energy of the reactants my stylus is gone. Okay, reactants minus the sum of the bond dissociation energy of the products. This is the opposite remember, this is the opposite of normal because for bond formation, we're looking at bond formations. Enthalpies of formations, which is what we're normally used. We're looking at bond dissociation energies, which are the energies to break. And we're actually wanting to form bonds. So that's the reason it's the opposite of how we normally do. And you can see all that in the lecture. The next thing we need to do is if we're going to do bond dissociation energies, we have to know the Lewis structures of our chemicals. So we have to reach back to last semester and draw out those Lewis structures. So I have 2 ammonias. If you don't remember how to draw Lewis structures, let me know, and I'll give you a link to my lecture on Lewis structures. So I've got 2 ammonias reacting with a chlorine. I am really sorry, guys. I am working with a Surface today, and my Surface stylus has stopped working. Therefore, I'm in this awkward position of having to use a generic stylus for us, which causes these little fun glitches here. And it definitely doesn't like doing dots. Yielding, so I've got my chlorine there, yielding hydrazine. Now, hydrazine, let me do the Lewis structure for that real quickly here. You've got, I'm going to take my electron inventory because I don't have that one memorized off the top of my head. So I'm doing that one up here. I've got 2 nitrogens. Each nitrogen has 5 valence electrons, so I've got 10 there. Then I've got 4 valence electrons from hydrogen, so I've got 14. My nitrogens are connected to each other, and each one's going to have 2 hydrogens attached to it. That costs me, my skeletal structure costs me 2, 4, 6, 8, 10 to build with. That gives me 4 left over. So I'm going to place those on my central atom. And that appears to be my structure for hydrazine. Let's see here. My hydrazine now currently isn't finished because each one currently has 2, 4, 6, 8, 2, 4, 6, 8. So we are actually pretty good there. So there's our Lewis structure for our hydrazine, plus the Lewis structure for our chlorine. And I'm going to make little X's here for electrons because my stylus just is not wanting to do dots. All right. So there's my hydrochloric acid. So now that I know my Lewis structures, I can do my number of bonds fairly straightforwardly and fairly fast. All right. So now we just have to do our reaction. So we've got our change in enthalpy. I went and got a new stylus. Oh, I spoke too soon. Equals the sum of the reactants, the dissociation of the reactants. So I have 1, 2, what's a 2? Come on, cooperate. Okay. Have a 2 there. And then I have a 3. So now I have 3 nitrogen-hydrogen bonds, but I have 2 molecules of my ammonia, right? So that means I have 6 of them total. So 6 times that value for my ammonia bond, for my nitrogen-hydrogen bonds. So I go look that up. From the chart they gave me, that's 390 kilojoules per mole. So that's that. Now we're going to go for the chlorine. This is easy. We only have 1 of those. So I get my chlorine-chlorine bond of 243. Then and I put big brackets around those. Now I'm going to subtract my products. So I come over here to this side, and here I've got 1, 2, 3, 4 nitrogen-hydrogen bonds at 390 kilojoules. Plus I've got a nitrogen-nitrogen bond. So I've got to take care of that nitrogen-nitrogen bond, which is 240, I believe. Then I have my hydrochloric acids, and I've got 2 of them. And each one of them has a value of 432 kilojoules. So big brackets around that part as well. So now it's just a matter of plugging and chugging and doing the math. And me going to Amazon to get a new stylus apparently too. Plug that all into your calculator, and I get actually, let me write this out symbolically for you. What we've done here, we've said 6 times the dissociation of the nitrogen-hydrogen bonds plus the dissociation of the chlorine-chlorine bonds minus four times the dissociation of the nitrogen-hydrogen bond plus the dissociation of the nitrogen-nitrogen bond plus 2 times the dissociation of the hydrochloric acid bond. But anyway, we punch all that into our calculator, and we wind up with a delta H of a negative 81 kilojoules. That's it. Beep.